Alright, this is the solutions video for the section 1.4a homework on page 76. The first 4, 5, 7, 8, and 9, we're looking at graphs. So just reading graphs. So number 5, part A, if we're coming from the right, C is 3. So from the right, the y value is 1, and from the left, the y value is also 1. And since they're equal, then your hands come together, and for all three parts, the limit is 1. All right, number 7. So number 7, from the right, as you approach 3, C is 3 again, the y value is 0. From the left, the y value also 0. Your hands will come together there, coming from the right and left. So for all three answers, the answer is 0. This dot here doesn't really matter. You're just following the function. So in this case, the limit does not equal f of x. All right, so that's going to be 0, 0, and 0. Number 8, from the right, the answer is 2. From the left, the answer is 2. Do your hands come together from the right and the left? Yes, they do. So part C, the answer is also 2. So we've got a 2, 2, 2. Let's see if number 9 is any different. There's a break in the function here. From the right, the y value is 3. From the left, the y value is negative 3. So we've got a 3, negative 3. Your hands don't come together, so this limit does not exist. So we've got 3, negative 3, and does not exist. So I'm glad we got at least one of those examples in. Okay, so for number 11, remember when you're finding these limits from the right or left, if it's not absolute value or a piecewise function, you just do it the same way that you've been doing it. So this is going to be the limit as x approaches 5 from the right of x minus 5. And we're going to factor into x plus 5 times x minus 5. The x minus 5s will cancel as long as x does not equal to 5. So that's going to be the limit as x approaches 5 from the right of 1 over x plus 5. So now we can plug the 5 in, and the answer would be 1/10. All right, easy peasy. Number 13, no absolute value, no piecewise. Let's see if we can plug in here. If we plug in a 2 on top, and then we plug in a 2 squared, so you're going to have 2 over 0. So that does not exist. So we didn't even have to do any extra work. We have the form non-zero over 0. Okay. Number 15. So that one, we have the limit as x approaches 0 of the absolute value of x over x. Well, it's got absolute value, so we are going to have to analyze from the right and from the left. From the right, it's a tiny positive number we're going to put in. Okay, tiny positive, so from the right, say 0.001, and also a tiny positive on the bottom. So that's going to be 1. From the left, on top it would be a tiny positive, because if we say negative 0.001, right, that'd be a little bit to the left of 0, negative 0.001, but when you take the absolute value, it's going to be positive. But on the bottom, it would be a tiny negative number. So tiny positive. So for example, let's say that's positive 0.001 over negative 0.001. Right? You put that in your calculator, it will give you -1. So they are not equal. So the answer is that the limit does not exist. All right, number 17. I hope I can fit this in. We have the limit as delta x approaches 0 from the right of 1 over x plus delta x minus 1 over x over delta x. So not absolute value, not piecewise, so we can just pretend this is 0. Now, the quick way of putting these fractions together, if I can remind you from pre-cal, take the denominators and multiply them together. So that's going to be x times x plus delta x. That's your common denominator. Bring this x on bottom up top. And then bring that x plus delta x up top on the right. So you just cross them. But we need to put it in parentheses because we're subtracting the entire thing over delta x. Now we can move that delta x up a level. Okay, so I'm going to have the limit as delta x approaches 0 from the right of, now I'm going to go ahead and do this, x minus x is 0, right? Well, I'll go ahead and write it out. X minus delta x, so the x's are going to go away, over x times x plus delta x, and then I move that delta x up top. So the x's will go away, and we have the limit as delta x approaches 0 from the right of negative delta x over x times x plus delta x times delta x. The delta x's will cancel as long as delta x does not equal 0. Got to write that proviso down. So finally we've got to the point where we can plug in that 0 for delta x, because I would have -1 over x times x plus delta x. If we plug a 0 in here for delta x, I've just got -1 over x times x, right? Because that's 0, just x times x. So that's x squared. All right, beautiful. That's a really good one to understand. Okay, number 18. All right, I've got a lot to write, don't I? Limit as delta x approaches 0 from the right of x plus delta x all squared plus x plus delta x minus x squared plus x over delta x. Now I'm going to FOIL that x plus delta x out. I believe this is by far the longest problem in our homework. If we FOIL that out, write it twice, but you would end up with x squared plus 2x delta x plus delta x all squared plus x plus delta x minus x squared minus x. So I'm distributing the x there all over delta x. Now let's clean all this up. So the x squared and the negative x squared cancel. I've got an x and a negative x that cancels. So all that's left is 2x delta x plus delta x all squared plus delta x over delta x. Let's factor out of the top of delta x. if we do that, we can cancel it out and get rid of that delta x on the bottom. That's what's causing us the problem. So we factor out a delta x out of this, you're left with 2x, out of this a delta x, and then don't forget the 1. If you factor a delta x out of delta x, you're left with a 1. That does not go away. Over delta x, we can cross that out as long as delta x does not equal 0, right? And then finally, we are ready to plug in of 2x plus delta x plus 1, and that equals 2x plus 1. Okay, great. That's a really good problem. Doesn't really have much to do with the from the right or from the left. It's just a really good limit problem, and it's good for the future problems you're going to be working as well in Chapter 2. Okay, number 19. All right, we've got piecewise. The limit as x approaches 3 of x plus 2 over 2. And that's when x is less than or equal to 3. So that's from the left. And then we have 12 minus 2x over 3 when x is greater than 3. So that would be from the right. So the limit as x approaches 3 from the left, that's the top one, of x plus 2 over 2. We're just going to plug a 3 in. So that would be 3 plus 2, 5 halves. And then the limit as x approaches 3 from the right, we would use the bottom equation, 12 minus 2x over 3. That's going to be 12 minus 2 times 3 is 6, so 6 over 3, which is 2. So we have 5 halves and 2. Those are not equal, so this limit does not exist. Because they are not equal. Your hands wouldn't come together on that graph. Okay, can I fit 21 in? I've got the limit as x approaches 1 of x cubed plus 1 when x is less than 1. So that's from the left. And then x plus 1 when x is greater than or equal to 1. All right, so from the right. So we'd have limit as x approaches 1 from the left. We're going to use the x cubed plus 1 equation. So that'd be 1 cubed plus 1, that's 2. And then the limit as x approaches 1 from the right, bigger than 1, we're going to use the bottom equation, x plus 1. That's also 2. They're equal. So the answer is 2. The limit is equal to 2. All right, brilliant. Okay, we are almost done. Just 3 more problems to work. I don't think they're too long either. So number 22. We have the limit as x approaches 1, another piecewise function. We've got x when x is less than or equal to 1, and 1 minus x when x is greater than 1. So that'd be left, right. Okay, let's do them. X approaches 1 from the left of x. Plug in a 1, that's 1. The limit as x approaches 1 from the right, 1 minus x. Plug in a 1 for x, and you're going to get 0. All right, so they are different from the left and from the right. They are not equal. Your hands would not come together on that graph, so the answer is does not exist. All right, 23. We've got the limit as x approaches pi of cotangent x. Well, in this case, you know, there's no from the left or from the right here. We're going to just see if we can plug in. This is the limit as x approaches pi. I would do this as cosine x over sine x. So we can plug in pi. Cosine of pi is -1. Sine of pi is 0. That's non-zero over 0, so does not exist. So again, we don't have to look at it from both sides because it's not piecewise or absolute value. And then we have finally the limit as x approaches pi over a deuce of secant x. Let's change that to cosine so we can look at the unit circle. So it'd be 1 over cosine x. What's the cosine of pi over 2? Well, it's 0. So that is a does not exist. Okay, so that does it for the homework solutions for this homework set. I hope this helped you out. If you had any questions, and I will talk to you next lecture.